All right, welcome to part 5 of practice exam 4. This is going to be questions 41 through 50, so let's just jump right in. Question 41 says use the range rule of thumb to approximate the standard deviation. And if you remember, the rule of thumb says you take the range, and we're going to take that range, divide it by 4, and that's going to be an approximate standard deviation. Not exactly, but you know, when you are trying to calculate something very quickly, finding the range is easy. You take the top minus the bottom, so 22 minus 1, which is 21. And then we divide that by 4, and that would give us an approximate standard deviation. In this case, approximately 5.25 is going to be that standard deviation, and so D would be the correct answer there. All right, consider the box plot. We're in question 42. For ACT scores of 3 different high schools, and select the statement that is not true. So we're looking for what's not true. School A has the greatest range. So there's the range. Just by a quick glance, it looks like that is true. So I'm going to cancel that one out. The median for school B, so that's the middle value right here, is the same as the upper quartile for the other 2 schools. There's the upper quartile, and there's the upper quartile. That looks true, so that's not one of our answers. School B has the highest max. Here's the highest max. Actually, both of the other schools have higher maxes than this one does. So my guess is that that one's the one that's not true, but let's just verify with the last value. School A has more variability between the second and third quartiles than School C. So here's the second and third quartiles, variability, working between those, okay, and you can see that the other ones have shorter, so yes, that one is true. So C is the one that is not true. Question 43. At one college, GPAs are normally distributed with a mean of 2.9 and a standard deviation of 0.4. What percentage of students in the college have a GPA between 2.5 and 3.3? Well, you'll notice that that's one standard deviation below the mean and one standard deviation above the mean. So if you can see that, we're going one standard deviation both ways. So this is question 43. One standard deviation away is 34% lower and 34% higher. So using the rule of 68, 95, 99.7, we're going to say that this is a 68% on that statistic because we're one standard deviation away. All right, 44. The amount of Jen's monthly bill is normally distributed with a mean of $56 and a standard deviation of $12. Fill in the blanks. 68% of her phone bill, 68% of her phone bills are usually between these values, one standard deviation away. So we're going to just take, for question 44, we're going to take and our mean of 56 and subtract 12. And then take our mean of 56 and add 12. And that's going to be our range. For, remember, we're doing 68%, so that's why we're doing one standard deviation away. And this one will be a total of $44 on the low end and 68 on the upper end. So 44 and 68 is D. Our next value question is the data value is 0.6 standard deviations below the mean. Okay, so that actually is our Z value. Okay, when it says one data value is 0.6, we want to find the standard score and the percentile. So that standard Z is 0.6. So, I'm sorry, but it's below the mean, so it's negative 0.6. So A is not the case. C could be. B is not the case, and D is not the case. Actually, we already know our answer. But let's also just look that up. If you go look at the table, negative 0.6 on the table will relate to 27.43%. Assuming that a math SAT scores are normally distributed with a mean of 500 and a standard deviation of 100, a score of 560 represents what percentile? So first we need to find the Z score. To do that, what we do is we take the value, so we're on question 46, take the value, 560, subtract the mean, which in this case is 500. And we're going to divide that by our standard deviation, which in this case is 100. So once we have that, we're going to get 60 divided by 100. Which reduces down to 0.6. So that's our score. So it's a positive 0.6. Now we go look at the percentiles on our table, and 0.6 is at 72.6. All right, let's go on to question 47. Matt recently took a very challenging chemistry test in which he scored 75%. His class mean was 68% with a standard deviation of 8.6. His friend Mike took this very similar exam on a different chemistry class and scored 70%. The class mean for that one was a 64 and a standard deviation of 10.3. With that understanding and both tests being measured with the same kind of ability between Matt and Mike, who had the higher test score in comparison with their respective classmates, that is the highest percentile among the test population. Okay. So we need to calculate the percentile or z-score for each of those. So we'll start with Matt. So this is question 47. We're going to start with Matt. And Matt has a z-score. We're going to take his value, which was a 75, minus his mean, which was a 68, and divide that by his standard deviation, which in this case was 8.6. So 75 minus 68 divided by 8.6 gives us his z-score of 0.8139. So I'll just put it right there. Now if we go calculate that on our table, 0.81 z-score will give us roughly about 79% or 79th percentile. All right, let's go calculate Mike. So Mike had a 70, and the mean on his class was a 64, and the standard deviation was a 10.3. So on his, we're going to calculate this, 70 minus 64 divided by 10.3, and his standard deviation is 0.58. If you go look at the table, that's roughly about 72%. So he landed in the 72nd percentile, Matt landed in the 79th percentile, so who did better on the test? In this case, it was Matt. All right, question 48. In a poll of 358 adults, 44% said they favored a proposed environmental law. Give an answer as to decimal of 3 decimal places. Find the margin of error for the survey result. Okay, since they don't explain it, I'm going to assume they want a 95th percent confidence. Which margin of error for that? Margin of error for 95th, remember, is 1 over the square root of n, where n is our sample size. If it was 68, then it would be 1 over 2 square root n. And if it was 99.7%, then you do 2 divided by the square root of n to get those confidence levels. And so here we go. So this means we're going to be 95% confident. So our sample size is 358 adults. 1 divided by the square root of 358. So we'll come over here and 358 square root. Okay, and I'll save that value in my memory. 1 divided by that 18.9 will give us 0.0528, and we're going to just go to the nearest 3 decimal places, but in this case, that rounds to a 3 decimal places. Okay. 49. True or false? If you want to reduce a margin error of a poll from 5 to 2.5%, so we're cutting in half of our margin of error, we should increase the survey with twice as many participants. And actually that is false. And the reason why is because If we were to double our participants, notice by taking the square root, our margin of error would only be the square root of 2, or 1.7. If we want to double that, we're actually going to have to take this and times it by 4, because the square root of 4 is 2, and then would be doubling our margin of error. So just think about that, because we're square rooting the sample size. During the questioning, 71 potential juror members, 50% said they had already formed an opinion of the guilt of the defendant. We want to find a 95% confidence interval for the true population of that value. So first we need to find the margin of error, 95 percentile, so we're going to use the same value. We 71 polled, 71 potential members said that, so we're going to take the square root. So 1 divided by 71 square root equals, so that right there, 11.8%, or 11.9 roughly if you round up, which I will, 11.9% is our margin of error. Now 50% said they'd already formed an opinion, so we need to go 11.9 below that and 11.9 above that to find our margin of error. So we're 95% confident that it falls between 38.1% and, if you add that to 50, 61.9%. So we're 95% confident that it's going to be between one of those two numbers. It's not saying much, but you know, it's anywhere between 38 and 61%. Okay, so we could go either direction, and plus we're even 95% confident, which means there's a 5% chance we're wrong in this. Anyway, that's part 5, and we have 4 more questions, so I will create a part 6.